Hello, this video is going to deal with basic harmonic analysis of contemporary music in contemporary styles as would be used at Berklee College of Music and other modern institutions of music study. As a way to gauge whether you understand this system, try analyzing this progression right now. If you have no idea, you can just carry on with the video, but if you think you can do it, you can go ahead and listen to this and then pause the video and see if you can analyze it correctly with Roman numerals and graphics. Okay, we're resuming now. So the first thing to realize is that we're in the key of C major. We know this because we've tonicized the C major chord by using a dominant chord to resolve down a perfect fifth to it. So there's some basic harmonic concepts we have to be aware of. The first is dominant function. When you have a dominant structured chord, which is a major triad with a minor seventh, it creates expectation of resolution down a perfect fifth to another chord down a perfect fifth. That's a basic assumption of dominant function. A dominant chord creates expectation of resolution to a chord whose root is down a perfect fifth. In this case, this is a diatonic chord. It's 5/7 of 1 in the key of C, and it wants to lead to C. Now, the reason for that is beyond the scope of this video, but I have other videos that describe why that is. It essentially has to do with the tendency tones inside the chord creating the expectation that each note will resolve in a particular way, and when they're allowed to resolve as they are expected to do or as we hear them wanting to do, we arrive at a chord down a perfect fifth. So it's built into the chord structure. It's not somebody's opinion that it does this. It's actually something that we all, at least in the Western hemisphere and Western musical traditions, hear as something that's a common expectation that we all share. Okay, so that's what dominant function does. There's also another harmonic function, which is called subdominant function, and one of the main representations of subdominant function is the 2 chord of a key. And subdominant function has many aspects, but one of them is a great predominant chord, a chord that leads very nicely to a dominant chord. And this one has come into particular favor, come into favor, especially in the 20th century with American songbook music and jazz. And what it is the 2 chord leading to the 5 chord, also known as a 2-5 relationship. Now, in order to have a 2-5 relationship, the chord that is the related 2 chord must be a chord with a minor third. So it could be minor 7, minor triad, or a minor 7 flat 5 chord, or a diminished triad. Any of those chords have a minor third. So it must be that. It must be a chord of that type. Another thing that must happen is that the chord must be a perfect fifth above the dominant chord that follows it. And the third thing that must happen is a dominant chord must follow it. Otherwise, it's not a related 2. It can only be a related 2 in relation to something, and in this case, in relation to a dominant chord down a perfect fifth. So that's a related 2. That's the description of it. Here's the checklist. It must have all 3 of these things. It must fulfill all 3 of these requirements. If it fails in even one of these ways, it is no longer related to. If this was suddenly a D major chord, it would not be related to. If this was suddenly a D7 chord, it would not be related to. If this was suddenly a D flat chord, it would not be related to because it would no longer be a perfect fifth above. If this was not a dominant chord, this could not be related to. All right, so all 3 of these things must be true in order for a chord to be a related 2. Ask yourself, is this chord a related 2? And the answer is yes. It fulfills all 3 requirements. It's a chord with a minor third. It's a chord that is followed by a dominant chord, and the interval between them is down a perfect fifth. What about this chord? And the answer is yes, that is also a related 2. It's a chord with a minor third. It's a perfect fifth above the following dominant. Okay, we have a special symbol for this at Berklee, and it's called the bracket, the related 2 bracket. And it looks like that. This captures that particular relationship. We only draw that when all three of these requirements are met. We also have a special symbol for when there's a dominant function chord that actually does proceed down a fifth as we expect it to do. It's called the dominant arrow. Looks like that. We only draw this when the dominant chord does in fact go down a perfect fifth. Would we draw it here? And the answer is no, because it's not going down a perfect fifth. Would we draw it here? And the answer is yes, because this chord is going down a perfect fifth. Okay, the next part of the analysis structure is Roman numerals. So the Roman numerals relate to the chord's function in the key. And again, I'm not going to go over every possible harmonic function, but most of these chords are, in this progression, are either diatonic, so those are easy. That's 2 minor 7. This is a 5-7 chord. This is a 1 major 7. This is a 3 minor 7. This is a 7 minor 7 flat 5. It's another diatonic chord. And this is a 6 minor chord. So those are pretty straightforward, right? The remaining chords are non-diatonic, but they have diatonically related function. They're called secondary dominants. And what they are diatonic chords that have been altered to become dominant chords and thereby create that expectation that they will resolve down a perfect fifth. These are chords that have been supercharged to target a diatonic chord. So in this case, this used to be E minor 7. It was changed into E7 with a leading tone G sharp that leads very strongly to 6. So this chord is analyzed not as 3-7, but as 5-7 of 6. You can see right there. There's actually 5 secondary dominants in any major key, and they're all analyzed in this way. So they are analyzed in a way that helps us understand that their purpose is to lead strongly down a fifth to a diatonic chord. If we just called it 3-7, that would not be communicated. But by calling it 5-7 of 6, we are underlining the fact that this chord creates an expectation in our ear that the next chord will be the 6th chord, and that's a very powerful harmonic tool. Now, sometimes dominant chords go as expected, but sometimes they don't, like here. Think about it for a minute. What would this chord typically lead to? If it did what dominant chords are expected to do, it would lead down a perfect fifth. And where would it land if it did that? What would be the root of the chord that it would land on if it goes down a perfect fifth? And hopefully you figured out that it would land on D, and of course D is the 2 chord. So this is actually still 5-7 of 2, even though it's not going to 2. Its expectation is still that it will go to 2, but it resolves deceptively. And so there's an additional symbol for that. When a dominant chord resolves deceptively, in other words, it does not go to the expected chord down a perfect fifth, we put that Roman numeral in parentheses as a way to communicate that it is in fact resolved deceptively. So we do this. Oops. And that deceptive resolution, those deceptive resolution brackets are an important part of the analysis, because not only are we not drawing the arrow, because the arrow signifies that it has gone down a perfect fifth, but we are underlining the fact that it's resolving deceptively by putting it in parentheses. The brackets can also have another meaning, which is change of function. That's when a chord seems to be doing one thing and ends up doing something else, or ends up acting in a different way and performing a different function. Now, there's one more thing to do. As you may have noticed, there's one chord that has not yet been named. So let's see how you do with that. Can you name that chord, and then can you analyze it? Pause the video and then start it again to check your answer. Okay, hopefully you realize that this is a B7 chord. It's not a diatonic chord, as you can clearly see by the accidentals. This is a secondary dominant chord. Does it resolve as expected? Yes, in fact, it does go down a perfect fifth, so we are in fact going to draw our dominant arrow. What would its Roman numeral be? Would it be 7, 7, or something else? Hopefully you remembered it would be 5, 7 of 3. That's the way we analyze dominant chords, secondary dominants. And is there anything deceptive about its resolution? No, it is not. It's going to 3 as expected. So here's our entire progression now. And hopefully you noticed how this sets up the expectation that we're going to go somewhere down, and that when we go that it feels like a resolution. Whereas this sets up an expectation which is different from what we expect. This is a deceptive resolution, and this is a expected resolution. Same with this one. So that's it. Those are the main attributes of contemporary analysis as far as I was able to go in this relatively short video. Just to recap, there's a related to function which is captured with a bracket. In order to be a related to, a chord must fulfill all three, every single one of these three requirements. It must have a minor third, the second chord after it, the next chord after it must be a dominant seventh chord, and the interval between them must be down a perfect fifth. In other words, the related to must be a perfect fifth above the following dominant chord. We have the dominant arrow. The requirement there is that the chord be a dominant chord and that it proceed down a perfect fifth. Root motion down a perfect fifth. We have Roman numeral analysis for diatonic chords, and then we have 5, 7 of this or that for dominant chords, secondary dominant chords. And we have the deceptive brackets for dominant chords that do not resolve as expected.